Hi, this is the solution video for Q39 Mathematics question number 39. It's a Mark 2 question, and this problem is related to extreme value problem, okay? That is in the broad areas multivariate calculus, okay? So let's read the question first. The question reads as follows. Suppose C is a curve which intersection of two surface x z square equal to x or y square and the plane, and we have point P on this curve, which is the minimum distance from xy plane. We need to find the distance of P from the origin. That means that what is the situation? Situation is we have the double cone like this, and it is intersected by some planes, given plane. And the point is the point P is here. We need to find the distance. That is the thing we need to calculate. Therefore, option we need to check. Okay. So before solving the problem, let's see the NPTEL course references which can be used as study material. So these are NPTEL course references. All relevant information are getting displayed, and also the YouTube link is given. You can directly go to this YouTube link and watch the corresponding lecture in order to get a grasp of the relevant study materials. Okay. Now let's see the important facts which you are going to use for solving this problem. So first thing is that the surface d equal to x y squared looks like this, and it's called a double cone. Okay. And second information is second theory. So second fact that is important is that since we need to find the minimum distance from xy plane, we need a minimum mod z, which is equivalent to minimum z squared, subject to the constraint z equal to x y squared and 4z equal to 7. Okay, so those are the two important facts. Basically, the second fact is the more important. Okay, so now let's solve the problem. So what is the following process? The first process is the elimination of z. And secondly, after eliminated, we need to minimize z squared. Okay, so we have the equations for 4x plus z equal to 7. That tells z equal to 7 minus 4x. And we have the equation x squared plus y squared equal to z squared. We are putting this value 7 minus 4x in z, and we are getting this equation. And that tells y squared in terms of f of x. But since y is real, this right-hand side should be greater than equal to 0. Okay. Now this greater than equal to 0, that happens, this greater than equal to 0, that happens only when x lies in the region. Okay. Why it coming? So it's basically this thing is basically Sridhar Acharya formula from class 9 and textbook. You can go through that and use that. Okay, it's a very well known and famous formula. So there is nothing to explain much about that formula. Okay, so basically what we're getting is that why. So we have the x value must lie in this region. That is the only thing for y to be greater than equal to 0. Correct. Now look at the expression of z. This d square equals 7 minus 4x squared. Okay. That means what this that means this expression is convex, and z equal to 0, that implies x equal to 7 by 4. Okay, but 7 by 4, but this interval does not contain 7 by 4. So what we'll do, you will check separately at the point 7 by 5 and 7 by 3. Okay, so what we're doing, we choose first x equal to 7 by 5. For that we found some z. Then we choose x equal to 7 by 3. For that we found some z equal to minus 7 by 3. Then we are choosing the distance d equal to root over x squared y squared plus z squared, which is root 2 modulo z. And so we will get 7 root 2 by 3. Okay. So the point is that 7 by 5, of course, less than 7 by 3. So that's why we choose this value of mod z to this. Okay. So that's why root 7 root 2 by 5. So this is the final answer. Okay. So now let's get back to the options. So option B is 7 root 2 by 5. It is correct option. And so this is the whole argument for the question, for this question. Thank you.